Hello everyone! In this video, we will talk about exponential functions. This is the 6th module of General Mathematics, Quarter 1. Our first lesson is all about representing exponential functions through table of values, graph, and equation. Exponential function is a function of the form f of x equals b to the power of x, wherein b stands for the base, or y equals b to the power of x, where b should be greater than 0 and b should not be equal to 1. Let us start with the table of values. To see if the given table of values represents an exponential function, look for a common ratio in f of x that provides the sequence of numbers which increases very rapidly. This time, help me identify if the given table of values represents an exponential function or not. Let us review that to identify if a table of value represents an exponential function, we should look for a common ratio. So let us have our first item. We have our x values are 0, 1, 2, 3, 4, and 5. So let us see if our values in f of x have a common ratio. Is there a common ratio of these values? The answer is yes, there is a common ratio, and that is 2. So observe from 1, we have 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So, is it an exponential function? Yes or no? The answer is yes, it is an exponential function since there is a common ratio which is 2. Now, let us have another item. We have our x values are the same and our f of x are 0, 1, 2, 3, 4, 5. Do they have a common ratio? The answer is no, they don't have a common ratio, so that is why this table of value is not an exponential function. Let's proceed to item 3. We have our y values, or the values of our function, are 1, 3, 9, 27, 81, 243. Observe carefully if there is any common ratio. The answer is yes, there is a common ratio in here, and that is 3. So let us see. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. Since this table of values have a common ratio, therefore, it is an exponential function. Let us have our fourth item. We have our y values are 1, 5, 9, 18, 81, 243. Do they have a common ratio? The answer is no, they don't have a common ratio, and therefore it is not an exponential function. Let's proceed to item number 5. We have our y values are 1, 5, 25, 125, 625, 3125. Do they have a common ratio? The answer is yes. Observe that 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125, 125 times 5 is 625, 625 times 5 is 3125. And since there is a common ratio, therefore, it is a representation of an exponential function. Now, you already learned how to identify if a table of values represents an exponential function. Let's proceed to graphs of exponential function. Observe that we have two graphs in our screen. The first graph is the graph of the function 2 to the power of x. And the second one is for the graph of the function 1/2 to the power of x. Graphs of exponential function have always a curved shape. This time, let's identify if the given function is exponential or not. Number 1, f of x equals 2 to the power of x. What do you think? Is it exponential or not? The answer is yes, it is an exponential function. We have our base 2 and our exponent is x. How about the second item? Is it exponential or not? The answer is nope, it is not an exponential function. Our base is x and our exponent is 2. How about the third one? Is it an exponential function? The answer is yes, it is an exponential function. Our base is 1/3 and our exponent is x. How about the fourth item? F of x equals 2 to the power of 4. Is it exponential? The answer is nope, it is not an exponential function. Observe that there is no variable x in this function. How about for number 5, the last item? Is it exponential or not? The answer is yes, it is an exponential function. Observe that all exponential functions here have x variable in their exponents and not in the base. Let's proceed to lesson 2, determining the domain, range, intercepts, zeros, and asymptotes of an exponential function. Let us find the domain, range, intercept, zeros, and asymptotes of the following functions. We have 1 f of x equals 3 to the power of x plus 2. And for number 2, f of x equals 1/3 to the power of x plus 1. Let's start with the first item. We have f of x equals 3 to the power of x plus 2. So let us construct a table of values first. We have our x values are from -6 until 2. So it's up to you where to start and where to end. Then substitute the x values to the function to get the values of y. We have, for example, 3 to the power of -6. You can solve it in your calculators. Solve for 3 to the power of -6 equals plus 2 of the previous answer. So we have 2.00137. Let us try the x equals 0. So 3 raised to the power of 0 is 1. So any number raised to the power of 0 is 1. Plus 2, so we have, our answer is 3. Another example, we have 1. 3 to the power of 1 is 3. Plus 2, the answer is 5, and so on. After constructing the table of values, you can now construct a graph of the function using the points that you get from solving or the points that are presented in our table of values. Okay. Domain. The domain of exponential functions are all real numbers. You can also observe that in our graph, where our graph extends from the negative x values up to the positive x values. The statement all real numbers can be represented by the interval notation negative infinity until positive infinity enclosed with parentheses, or by set notation, which is like this: x is any element of real numbers. As for the range, so let us observe the graph with respect to the y-axis. So we can see that the graph only approaches 2, but it will not cross 2. So which means this graph will not go down below 2. So which means our range is just from 2 up to infinity. So we have 2 until infinity enclosed with parentheses, since this graph will not actually cross y equals 2. Or in set notation, we have y is any element of real numbers such that y is greater than 2. Let's proceed to intercepts. Our x-intercept as well as the zeros is none. Why? Because our graph didn't cross the x-axis. Therefore, we don't have any x-intercept. As for the y-intercept, observe the y-axis. Our graph crosses at 3. Therefore, our y-intercept is y equals 3, or in point we have 0, 3. Or if you will not look at the graph, we can solve this from our function by substituting 0 to x. We have 3 to the power of 0 plus 2. 3 to the power of 0 is 1, plus 2 we have 3. As for the asymptote, our asymptote, we don't have any vertical asymptote since this graph will extend to the right as well as to its left. But we do have our horizontal asymptote since, again, this graph will not cross below 2. Therefore, 2 is our horizontal asymptote. Hope you understand our first example. Let's proceed to our second example, which is f of x equals 1/3 to the power of x plus 1. Same thing as we did with the first example. Let us construct a table of values. You can assume any values of x, it's up to you. Then for the y values, you can solve this by substituting x values to the function. For example, we have for -3, 1/3 raised to the power of -3 plus 1. We have -3 plus 1 is -2. 1/3 raised to the power of -2 is 9. Let us have -1. 1/3 raised to the power of -1 plus 1. -1 plus 1 is 0. So 1/3 raised to the power of 0 is 1. Again, any number raised to the power of 0 is 1. After constructing the table of values, we can now construct our graph. Then let us identify the domain. The domain is the set of all real numbers, again, since it extends from the left x values to the positive x values. And same for the interval notation, we have -infinity until infinity enclosed by parentheses. Then for set notation, we have x is any element of real numbers. As for our range, let us observe our graph with respect to the y-axis. We can see that our graph approaches 0, or our x-axis, but it did not cross it. Therefore, our range is from 0 until infinity, enclosed by a parenthesis. Or y is any number greater than 0. Let us have intercepts. So as for the x-intercept and zeros, It is none since our graph did not cross the x-axis. It is just approaching our x-axis, but it did not actually cross it. Therefore, we have no x-intercept. As for the y-intercept, let us observe the y-axis. Our graph crosses the y-axis at this point, which is it is 1/3. And we can prove that by solving it using our function, substituting x with 0. So we have 0 plus 1 is 1. 1/3 to the power of 1 is still 1/3. So our y-intercept is 1/3 or 0 1/3. As for the asymptote, again, exponential functions do not have vertical asymptotes, but it do have horizontal asymptotes. Since our graph do not cross below y equals 0, so that is our horizontal asymptote. Y equals 0. I hope that you understand our examples. Let us have lesson 3, which is solving word problems involving exponential functions, equations, and inequalities. Exponential growth is defined as a quantity that grows by a fixed percentage at regular intervals. The pattern can be expressed by the function y equals a times 1 plus r to the power of t, where a is the initial amount, r is the rate, and t is the number of time intervals. Exponential decay, on the other hand, is defined as a quantity that decays by a fixed percentage at regular intervals. The pattern can be expressed by the function y equals a times 1 minus r to the power of t, where a is again the initial amount, r is the rate of the decay, and t is the number of time intervals. The computation of compound interest is a real-life application of exponential growth. The formula for the amount in compound interest is a equals p times the quantity of 1 plus r over n, where a is the amount in compound interest, t is time in years, r is the interest rate, p is the principal, and n is the period per year the interest is paid. We have daily. Is it monthly? If it is monthly, our n will be 12. If it is quarterly, our n is 4. If it is semi-annually, our n is 2. If it is annually, our n is 1. Let us have our first example. In 2020, the population of children in a town was 5,000. This population increases at a rate of 3% each year. What will be the population of children in year 2030? So since this is about the population increase, which means it is exponential growth. So we will use the formula for exponential growth, which is y equals a times 1 plus r to the power of t. But before going on with our solution, let us extract the givens first. We have the initial amount. What is the initial amount of children? We have 5,000. For the r, our rate is 3%. And as for our time, it is 10 years because the initial amount was taken in 2020, and our problem is looking for the population of children in the year 2030. So 2030 minus 2020 is 10. That is why our time is 10 years. Now, since we already extracted the givens, we can now substitute them to our formula. We have y equals a, or a is 5,000, so substitute 5,000. Copy 1 plus the rate, 3%. Convert to decimal form, we have 0.03. So we have 0.03 raised to the power of time, which is 10. Let us simplify. 5,000, copy. Then 1 plus 0.03 is 1.03. Copy the power 10. Then copy 5,000. Let us solve first the 1.03 raised to the power of 10. Solve that using your calculator. 1.03 raised to the power of 10 is 1.343916. I suggest that you do not round off to the 10th digits because our final answer will differ at the decimal points. So I suggest using at least 6 decimal points or more. Then we have 5,000 times 1.343916. Our answer is 6,719.58. But since we are talking about children here, we do not use decimal points. So that 0.58 will be eliminated because we are talking about, again, children. There is no point children, point child. So we will use the 6,719. Therefore, in the year 2030, there will be 6,719 children in the town. Let's proceed to our second example or second problem. The price of a cell phone is decreasing by 1% per month. If the price is 8,000 today, what will it be in 6 months? Same procedure, we will extract the givens first. Our initial amount is 8,000. Our rate is 1%. Convert to decimal, that is 0.01. Our time is 6 months. So since we are talking about here the decrease of the price, therefore this problem belongs to exponential decay. So we will use the formula y equals. Substitute all the givens to the formula. We have our A is 8,000. 1 minus R is 0.01. Our time is 6. 1 minus 0.01 is 0.99. 0.99 raised to the power of 6 is 0.941480. Then multiply to 8,000. Our answer is 7,531.84. Let us round off. This will become 7,532 pesos. After 6 months, the price of the cell phone will be 7,532 pesos. Our third example, in a nuclear test explosion, this substance has a half-life of 30 years. What part of the substance remains after 60 years? Let us get all the givens. We have our initial amount is 200 grams. Do not be confused with negative 90 because this is just the name of the substance, strontium negative 90. So our A here is 200 grams. Our rate is 50% because this is half-life. So what is half? That is 50%. That is why we use 0.50 for our rate. As for the time, we have 60 years divided by the 30 years because 30 years is the half-life of our substance. So we have again the 60 years over the 30 years, which is the half-life. We will use the formula for exponential decay in this problem. Substitute all the givens to the formula. We have A is 200, R is 0.50, then T is 60 over 30. 1 minus 0.50 is 0.50 also. 60 divided by 30 is 2. 0.50 raised to the power of 2 is 0.25. 0.25 for 200 is 50 grams. That means after 60 years, only 50 grams of the substance remains. Our fourth and last example, if 50,000 is invested at an annual interest rate of 3% and compounded quarterly, find her balance after 5 years. Let us get all the givens. We have our principal is 50,000, our rate is 3% or 0.03, our time is in 5 years, our N is in quarterly, compounded quarterly, that is why we will use 4. We will use the formula A equals P times the quantity of 1 plus R over N raised to the power of N times T. Substitute all the givens to the formula. P, which is 50,000, R, which is 0.03, and N is 4. Same here, 4. Then our T is 5 years. Simplify. 0.03 divided by 4 is 0.0075. 4 times 5 is 20. 1 plus 0.0075 is 1.0075. Raised to the power of 20 is 1.16118414. Multiply to 50,000. We have 58,059.207. Or round off, we have 58,059.21. After 5 years, her balance will be 58,059 pesos and 21 centavos. That's all for this video. I hope that you learned something. Thank you.